IVs bearing 290, multiple contacts closing fast.
The compression on cylinder 3 is still low.
Doc, we don't have time for a rebuild. We have to make it work.
Try reseating the valves again. Quickly.
The U-boat activity here is escalating.
We need to reroute the convoys through this sector immediately.
Agreed. Send the orders.
January 1940. A thin layer of frost clings to the wings of a skeletal aircraft on a dimly lit airfield outside Los Angeles. The night is quiet, broken only by the soft hum of distant generators and the clatter of tools on steel. Mechanics, bundled against the winter chill, move with urgency, their breath clouding the cold air as they tighten bolts and inspect engines. In the shadows, a pilot adjusts his leather helmet, fingers trembling slightly as he checks instruments that have yet to prove themselves in combat. Radar operators glance at flickering screens, glowing blips tracing the emptiness above, testing systems that promise to see what human eyes cannot. Above them, the sky is ink black, indifferent to the fears below. America has no long-range fighters capable of patrolling these nights. The world is at war, yet the United States remains unprepared, its skies exposed. And somewhere in a Northrop hangar, engineers are sketching lines and calculating angles that will one day bring a silent hunter to life. The P-61 Black Widow. This aircraft, unknown and untested, may become the answer the night demands. By January 1940, Europe was already engulfed in flames. The German war machine, perfected under the doctrines of Blitzkrieg, had overrun Poland in September 1939 with terrifying speed. Britain was bracing for an air war of unprecedented scale. Night raids, reconnaissance flights, and the threat of strategic bombing were no longer abstract threats. They were daily realities. The Luftwaffe ruled the skies with aircraft like the Heinkel He-111 and the Dornier Do-17, planes capable of striking deep into enemy territory under cover of darkness. Across the Atlantic, the United States watched with a mixture of apprehension and detachment. America was not at war. Isolationist sentiment dominated the political discourse. The Neutrality Acts of the late 1930s had constrained the U.S. military from active engagement. Yet, military leaders quietly understood the growing risk. If Europe fell, the security of the Americas would be under a shadow. And in this shadow, the U.S. Army Air Corps faced a glaring deficiency. The Air Corps in 1940 was a patchwork of outdated biplanes, early monoplanes, and experimental designs. Long-range escort fighters were virtually non-existent. Night fighter capability was nearly absent. American aircraft could patrol the coasts and strike lightly defended targets, but the technology to detect, intercept, and destroy enemy bombers in total darkness simply did not exist. Pilots training for night operations often relied on hand signals, flares, and the faint glow of searchlights, measures wholly inadequate against modern, fast, and well-armed enemy bombers. Strategists began mapping out the consequences. If war reached U.S. shores, the country's industrial heart and population centers would be vulnerable. The Atlantic approaches, home to convoys supplying Britain, were particularly exposed. A bomber could cross the ocean under the cover of night and return undetected, striking vital ports before a single warning could be issued. The calculus was grim. Speed, technology, and innovation would decide whether America could survive its first true night air battle. Northrop Corporation, based in Southern California, had been quietly developing advanced designs since the late 1930s. Jack Northrop, the company's founder, had a vision of all-metal, twin-engine aircraft capable of carrying heavy armament with unprecedented stability. Previous designs had impressed the Army Air Corps, but none had been intended for the night fighter role. When the problem of long-range night defense became urgent, Northrop's engineers were tasked with translating their sleek, high-speed concepts into a functional combat aircraft for a war that had already begun elsewhere. The government's orders were clear but daunting. Develop a twin-engine fighter capable of operating at night, intercepting enemy bombers at range, and integrating emerging radar technology. No U.S. plane had done this before. Prototype drawings had to anticipate speed, altitude, and maneuverability while accommodating a crew of 3: pilot, radar operator, and gunner. Armament needed to be concentrated yet flexible, accurate even when the target was invisible to the naked eye. Industrial pressures compounded the challenge. Factories were under strict schedules, materials were limited, and experienced technicians were already engaged in other war projects. Every bolt, panel, and system had to be precise. One error in design or construction could make the difference between a successful night intercept or a fatal crash. Meanwhile, military officers pressured Northrop to deliver results quickly. They did not have the luxury of years to experiment. The window to defend America's skies was closing with every passing month. At the same time, the science of radar was emerging from secrecy. Early sets could detect aircraft at ranges of a few miles, but the technology was bulky and delicate. Integrating it into a fighter meant sacrificing weight, adjusting aerodynamics, and training crews to operate a system that had never been used in combat. It was not merely an engineering challenge. It was a revolution in aerial warfare, a step into the unknown. By the end of the winter of 1940, Northrop's hangars were crowded with sketches, half-assembled airframes, and teams of engineers huddled over calculations. The problem was clear. America could not defend its skies at night. The solution, however, was beginning to take shape in metal, radar tubes, and relentless ingenuity. The P-61 Black Widow, though still invisible to the world, was emerging from the shadows, promising to meet a threat that the United States was only beginning to understand. The stage was set. The world was at war. America was unprepared, and one aircraft, born of urgency and innovation, would soon test the limits of engineering, tactics, and human courage. By mid-1940, the urgency for a capable American long-range fighter had intensified. Across the Atlantic, the Battle of Britain was raging. The Royal Air Force was stretched thin, combating waves of German bombers and fighters. Night raids had begun to take a devastating toll on British cities, and radar, then a fledgling technology, proved its worth in giving defenders precious seconds to respond. The United States, observing from afar, understood that similar threats could reach its own shores. Yet the U.S. Army Air Corps remained ill-prepared. Its fighters, like the P-36 Hawk and early variants of the P-40 Warhawk, were designed for daytime interception and short-range operations. Their engines lacked the endurance to patrol far from bases. Their instruments were rudimentary, and night navigation depended on skill, instinct, and hope. Anti-aircraft defenses were minimal, and early warning systems were fragmented. In essence, The American sky was wide open after sunset. Military planners considered various solutions. Some advocated modifying existing aircraft, attaching radar and heavier armament. Others suggested borrowing concepts from Britain, but U.S. production lines could not rapidly adopt foreign designs. Every approach encountered technical and logistical hurdles. Radar units were heavy, cockpit space was limited, and integrating a radar operator meant redesigning the aircraft's interior. Pilots had to trust instruments over sight, a radical departure from the flying experience they knew. The Air Corps leadership faced a dilemma: compromise speed and maneuverability for technological capability, or delay deployment while waiting for a more ideal design. Both options carried risk. Meanwhile, intelligence reports indicated that Germany's Luftwaffe was developing faster, more heavily armed night bombers. Time was not on America's side. It was in this environment that Northrop engineers began to refine their proposals. Drawing on their experience with twin-engine designs like the Northrop A-17 and the experimental XP-56, they envisioned an aircraft that could carry radar, crew, and concentrated firepower without sacrificing stability. The concept included a crew of 3, a pilot to fly, a radar operator to guide interceptions, and a gunner to deliver precise attacks. Armament would be concentrated in the nose and belly, enabling the aircraft to fire with accuracy at targets beyond visual range. Twin engines provided both speed and redundancy, essential for long-range patrols over hostile territory. Government pressure intensified the effort. The Army Air Corps issued specifications in early 1941, demanding prototypes within months, a timeline that defied standard aircraft development, which often took years. Northrop's engineers worked in near-constant motion, refining designs, performing wind tunnel tests, and improvising solutions to problems no team had encountered before. Materials were rationed due to pre-war shortages, and manufacturing errors could lead to catastrophic failure. Yet the sense of urgency created focus and determination. Every drawing, every rivet, every calculation was a step toward filling a critical gap in national defense. The challenge was not merely technical, it was tactical. American strategists had to imagine the scenarios in which the aircraft would operate. Intercepting enemy bombers at night over the Atlantic, navigating without visual references, coordinating with radar stations, and surviving in enemy territory. The P-61's design had to integrate seamlessly with emerging air defense doctrines, combining crew coordination, electronic guidance, and raw firepower. It was a revolutionary concept, a fighter built not just for speed or dogfighting, but for the invisible war of the night sky. By late 1941, prototypes began to take shape. Northrop's hangars were filled with skeletal fuselages, partially installed radar equipment, and a nervous energy of crews and engineers testing theories in real time. The United States had moved from a position of observation to action. The P-61 Black Widow was no longer a concept. It was becoming a tangible solution to a vulnerability that could no longer be ignored. The stage was now set for deeper exploration. The story of the Black Widow was not only one of steel, radar, and engines. It was a convergence of human determination, tactical necessity, and technological innovation. To understand its impact, We must examine the multiple angles from which this aircraft transformed the night skies and the men who dare to fly it. Behind the metal and radar tubes of the P-61 Black Widow were men whose ingenuity and courage defined its creation. Engineers worked long hours in Northrop's hangars, often without the certainty that their designs would even survive a first test flight. They were not just technicians. They were problem solvers forced to confront challenges no one had faced before. Wiring for radar systems, calculating weight distribution, and balancing engines against fuel capacity required precision and foresight. A single miscalculation could endanger the lives of the first crews to test the aircraft. Pilots, too, carried the weight of uncertainty. Unlike conventional fighters, the Black Widow demanded trust in instruments over instinct. Radar operators were a new kind of aircrew member, responsible for guiding the aircraft to unseen enemies in total darkness. Communication between pilot and operator had to be flawless. Early training exercises often ended in near disasters, but they forged bonds between crew members and instilled the discipline that would later be essential in combat. Every night sortie, every simulated intercept was a lesson in trust, coordination, and survival. The P-61 was a radical technological leap for the U.S. Army Air Forces. It was the first operational U.S. aircraft designed from the ground up as a night fighter. Twin engines provided the range and redundancy necessary for long missions, while a fuselage wide enough to accommodate 3 crew members allowed for the integration of radar and concentrated armament. Its landing gear and control surfaces were reinforced to handle heavier weight, and the aircraft structure was meticulously engineered to balance speed with stability, crucial when navigating in darkness. Radar technology was the aircraft's defining feature. The SCR-720 radar, installed in the nose, enabled operators to detect enemy bombers miles away, long before they could be seen visually. This required precise coordination. The radar operator would calculate vectors and relay them to the pilot, who maneuvered the aircraft into firing position. The technology was fragile, complex, and entirely new to American crews, yet it represented a paradigm shift in aerial warfare. Suddenly, night interception was not a matter of chance. It was science. The Black Widow's tactical purpose was clear: dominate the night skies. Traditional daytime dogfighting tactics were inadequate. Intercepting enemy bombers at night required a new doctrine. The P-61's speed and range allowed it to patrol critical sectors, respond rapidly to radar warnings, and engage enemy aircraft before they reached their targets. Pilots trained to attack from above or below, using the concentrated firepower of the 420mm cannons in the nose and .50 caliber machine guns in the ventral turret to neutralize threats in a single pass. Coordination with ground radar stations was essential. The U.S. Army Air Forces developed procedures to vector Black Widows toward enemy formations, effectively extending America's defensive reach. In the Pacific and European theaters, these tactics gave pilots the ability to disrupt bombing runs, protect convoys, and deny the enemy the cover of darkness that had previously made night raids nearly untouchable. Each successful intercept validated months of training, innovation, and high-stakes experimentation. The development of the P-61 Black Widow was as much a story of leadership as it was of engineering. Army Air Forces commanders recognized the urgent need for a dedicated night fighter and pressed Northrop to innovate under impossible deadlines. Brigadier General Benjamin Benny Chidlaw and other senior officers understood that failure was not an option. The skies over America and Allied supply routes could not remain vulnerable. They balanced pressure with support, providing Northrop engineers and pilots access to resources, prototypes, and testing airfields, while demanding speed and precision. Jack Northrop himself was a visionary leader within the company, insisting on rigorous standards and daring designs. He fostered an environment where engineers could challenge assumptions, experiment with configurations, and solve problems creatively. His insistence on a twin-engine, three-crew configuration and radar integration was initially controversial, yet ultimately proved prescient. The leadership at Northrop, combined with Army oversight, created a rare alignment of military urgency and industrial ingenuity, a convergence that would make the Black Widow a reality. The adversary the P-61 was designed to confront was formidable. Over Europe, the Luftwaffe had perfected night bombing operations, relying on darkness, flares, and evasive maneuvers to strike British cities. The threat was not just speed, but stealth. Traditional fighters could not detect or intercept bombers that operated beyond visual range. Intelligence reports emphasized that German bombers were increasingly equipped with defensive armament and coordinated in groups, further complicating interception. In the Pacific theater, Japanese aircraft introduced new tactical problems. While not initially as experienced in night bombing, Japanese forces could exploit the cover of darkness to strike shipping convoys and remote outposts. The Black Widow needed the versatility to operate across theaters, intercepting fast-moving bombers in the Pacific while maintaining the operational doctrine developed for European skies. Each enemy advance demanded adaptability, pushing the aircraft and its crews to continuously refine tactics and exploit technological advantages. Beyond tactics and technology, the Black Widow carried a moral weight. Civilians were increasingly at risk from night raids, and industrial targets were vulnerable to disruption. Creating an effective night fighter was not merely a military imperative. It was a protective measure, a commitment to defending lives and the nation's economic backbone. Each successful interception demonstrated the aircraft's potential to deter future attacks, offering both security and psychological reassurance. Strategically, the P-61 represented a shift in the U.S. approach to warfare. Instead of relying solely on daytime superiority or numerical advantage, America was investing in technological solutions that leveraged radar, crew coordination, and specialized design. It was a statement that the nation could innovate to meet unprecedented threats, that vulnerability could be met with ingenuity rather than sacrifice. In many ways, the Black Widow symbolized a turning point. The first American aircraft purpose-built to challenge the night itself, transforming defensive doctrine and setting a precedent for future developments in aerial combat. The first prototype of the P-61 Black Widow took to the skies on May 26, 1942, at Northrop's Hawthorne, California airfield. The roar of twin engines cut through the cool morning air as the aircraft lifted, a sleek silhouette against a pale dawn. For the engineers and military observers on the ground, every second of that flight carried the weight of expectation. This was not just a test. It was a proof that the United States could confront the night on its own terms. The aircraft handled differently from any fighter the Army Air Forces had flown before. The twin-engine design provided stability, yet pilots noted a heavier feel in the controls, particularly during turns and climbs. Early flights tested radar integration, though initial runs were rudimentary. Operators monitored blips on the nascent SCR-720 system, learning to interpret signals while the aircraft executed complex maneuvers. The crew quickly realized that night interception would demand coordination unlike anything they had practiced. Every pilot, radar operator, and gunner had to function as a single entity. As the prototype underwent more rigorous trials, engineers identified persistent challenges. Radar equipment was sensitive to vibration and temperature, sometimes giving false readings during maneuvers. Armament testing revealed the need for precise calibration. The 420mm cannons and dorsal turret required fine-tuning to deliver accurate fire without destabilizing the aircraft. Yet, each obstacle was met with iterative adjustments, calculations, and hands-on problem-solving. The Black Widow evolved rapidly, every test flight an essential chapter in its refinement. By late 1942, the first production models were ready for deployment. The Army Air Forces assigned them to the 7th Night Fighter Squadron, training crews at Orlando Army Air Base in Florida. These pilots and radar operators faced the dual challenge of mastering both the aircraft and the new tactical doctrine of night interception. Practice missions often simulated enemy approaches using searchlights, flares, and mock radar signals. Crashes and near misses were not uncommon, a stark reminder that this was a machine of cutting-edge innovation, operating at the edge of human capability. The first operational tests overseas began in Europe, late 1943, as the Black Widow arrived in England to support the 8th Air Force. Crews encountered conditions far harsher than any training mission. Freezing temperatures, low clouds, and blackout conditions that made visual navigation nearly impossible. Yet the aircraft's radar system, for the first time in American hands, allowed pilots to locate enemy bombers at night and at distance. The first successful intercept occurred in November 1943, when a P-61, vectored by ground radar, closed in on a formation of German Heinkel He-111s and Dornier Do-217s attempting a night raid. For accurate bursts of cannon fire sent one bomber spiraling into the channel, a historic confirmation that the concept worked. Each mission reinforced lessons learned during development. Pilots discovered the importance of positioning. Closing from above or below increased accuracy while minimizing exposure to defensive fire. Radar operators became adept at interpreting blips quickly, translating them into precise maneuvers. Ground crews adapted to maintain delicate equipment under wartime conditions, ensuring that the P-61 remained operational despite long sorties and harsh weather. The combination of technological innovation and human skill culminated in a moment of recognition. The P-61 was no longer a prototype. It was a functioning weapon capable of controlling the night skies. Its presence alone forced enemy bombers to reconsider routes and tactics. The Black Widow had transformed theoretical strategy into tangible results, proving that America could fight darkness on its own terms. The aircraft had passed its first test: flight, coordination, and initial combat validation. But the Black Widow's true impact would not be measured in isolated successes. It would be defined by sustained operational engagement, its performance in theaters across Europe and the Pacific, and the lives it would protect. By early 1944, the P-61 Black Widow was fully operational in multiple theaters. In England, crews of the 422nd and 425th Night Fighter Squadrons were flying nightly sorties over the European continent. The missions were perilous. Enemy bombers moved silently beneath a shroud of darkness, and German fighters often shadowed their formations, ready to intercept any threat. For the first time, American night fighters had the tools to detect, pursue, and destroy these aircraft before they could reach strategic targets. One of the most dramatic engagements occurred in February 1944 during a Luftwaffe raid on Allied airfields in Normandy. A pair of P-61s, vectored by radar operators on the ground, climbed into the frigid night sky. The pilots followed a stream of blips on their radar screens, maneuvering silently, their engines muffled by the cold. The first contact came without warning. A formation of Heinkel He-111 bombers appeared on the radar, just miles from the coast. The Black Widows closed in, and at precise range, the gunners unleashed concentrated fire. 3 bombers were downed in rapid succession, leaving the remaining aircraft scattered and retreating. It was the first large-scale night interception by U.S. forces, and it set a precedent for coordinated radar-guided operations. In the Pacific, the P-61 faced a different challenge. Japanese forces often launched surprise night attacks against shipping convoys and forward bases. The Black Widow proved equally effective in this environment. On April 14, 1944, over the islands of New Guinea, a Black Widow crew detected and intercepted a Japanese Mitsubishi G-4M Betty bomber attempting a low-level night strike. Using the aircraft's radar and superior firepower, the crew neutralized the threat before it could release its payload, saving both personnel and material on ground. These engagements demonstrated the versatility of the Black Widow, capable of adapting tactics to multiple theaters and enemy types. Combat also revealed operational limitations. Early radar systems were prone to failure in high humidity or heavy cloud cover. Engine reliability was a constant concern, particularly on long patrols far from friendly bases. Pilots learned to compensate, developing emergency procedures and refining night flying techniques under pressure. Despite these challenges, the aircraft consistently exceeded expectations, earning praise from commanders who had doubted the feasibility of a purpose-built night fighter. The psychological impact was immediate. Luftwaffe night crews, accustomed to near impunity over Britain, found themselves targeted in new ways. Japanese air units in the Pacific were similarly unnerved. Intelligence reports noted increased caution among enemy pilots, who altered flight paths and reduced attack frequency. The Black Widow was no longer just a defensive tool. It had become a deterrent, a force multiplier that reshaped enemy behavior without firing a single shot. By late 1944, the P-61 had established a clear record. Squadrons in Europe and the Pacific were credited with dozens of confirmed kills, countless disrupted raids, and invaluable reconnaissance missions. Pilots reported that the aircraft's stability and radar guidance allowed them to engage targets that would have been impossible to intercept with conventional fighters. Each sortie reinforced the effectiveness of the design, confirming the vision of Northrop and the foresight of U.S. military leadership. The turning point was unmistakable. An aircraft born of necessity had matured into a decisive instrument of war. The Black Widow had proven that night could be dominated, that technology and training could neutralize previously untouchable threats, and that American industry could deliver advanced solutions under the pressure of global conflict. Yet, even as the victories mounted, the story was far from over. Every engagement left lessons about radar operation, crew coordination, and tactical deployment that would inform subsequent missions. The aircraft's success illuminated both its strengths and vulnerabilities, setting the stage for a comprehensive assessment of its impact in the aftermath of battle. By the end of 1944, the P-61 Black Widow had firmly established its role in the U.S. Army Air Forces. Squadrons operating in both the European and Pacific theaters reported successful interceptions that had previously been impossible at night. The aircraft's operational record reflected a combination of innovation, training, and determination. In Europe alone, night fighter units logged hundreds of sorties, credited with downing over 50 enemy bombers in engagements where conventional aircraft would have been ineffective. In the Pacific, the Black Widow's speed and radar guidance allowed pilots to intercept Japanese aircraft attempting nocturnal attacks on supply convoys and remote bases, preventing potential disaster and saving thousands of lives. Despite its successes, the Black Widow was not without vulnerabilities. Early production models suffered from mechanical issues, particularly with engines and electrical systems. Radar units, delicate and sensitive, required constant maintenance, and failures were not uncommon during long missions in adverse weather. Pilots had to adapt to these limitations, often improvising mid-flight to complete missions. Training became critical. Crews that mastered coordination between pilot, radar operator, and gunner consistently achieved superior results, while inexperienced teams sometimes returned empty-handed. Casualties were inevitable. Night flying, inherently dangerous, claimed both aircrew and aircraft. Accidents during training exercises were frequent, highlighting the high-risk nature of operating a pioneering aircraft. Yet these experiences informed refinements in tactics, equipment maintenance, and crew procedures. Each loss underscored the importance of discipline, preparation, and technological understanding, gradually shaping a core of highly skilled night fighter units capable of executing complex operations under pressure. Beyond the statistics, the Black Widow began to change the calculus of war. Enemy pilots could no longer assume safety under the cover of darkness. Reports from Luftwaffe night crews in late 1944 described a growing wariness, noting that Allied night defenses had become significantly more effective. Japanese intelligence observed similar trends in the Pacific, leading to altered attack patterns and increased caution. The psychological effect of the Black Widow was as important as its physical firepower. It instilled uncertainty and fear in the enemy, a factor that amplified its operational value beyond measurable kills. At the same time, the aircraft influenced industrial and military thinking. Factories producing the P-61 worked under tight schedules to meet growing demand, refining assembly techniques and improving component reliability. The Army Air Forces recognized the strategic value of investing in specialized aircraft designed for specific threats. Lessons learned from the Black Widow's development and deployment would inform future designs, including jet-powered night fighters and radar-equipped interceptors, creating a lasting legacy of innovation born from necessity. By the close of 1944, the Black Widow had transitioned from experimental prototype to a proven instrument of night combat. Its combination of range, firepower, and radar guidance allowed the United States to project power after dark, something no other American aircraft could accomplish at the time. The aircraft had transformed not only operations in the field, but also the strategic mindset of military planners, demonstrating that technological ingenuity could overcome vulnerability and reshape the dynamics of war. The success of the P-61 set the stage for a broader evaluation of its impact, including the full cost of operations, overall effectiveness in multiple theaters, and its contribution to morale and strategic advantage. These consequences would define the next phase of the story. By mid-1945, the P-61 Black Widow had flown thousands of sorties across multiple theaters of war. Operational reports recorded over 100 confirmed enemy aircraft destroyed at night, with dozens more disrupted or forced to retreat. Squadrons such as the 418th and 549th Night Fighter Squadrons reported near-perfect coordination between pilot, radar operator, and gunner, a testament to the rigorous training programs developed alongside the aircraft itself. Each successful mission validated the concept of a dedicated night fighter, proving that the United States could exert control over darkness, a domain that had long favored the enemy. Losses, while significant, highlighted the inherent risks of pioneering technology rather than design flaws. Mechanical failures accounted for a substantial portion of crashes, particularly in early models where radar equipment was delicate and electrical systems temperamental. Weather, navigation errors, and the steep learning curve of night operations also contributed to attrition. Nevertheless, the majority of air crews survived and returned, armed with experience that would shape future aerial doctrine. Pilots, radar operators, and gunners alike emerged as specialists in a new form of warfare, their expertise influencing post-war night fighter development in both the United States and allied nations. Strategically, the Black Widow had a ripple effect far beyond its immediate combat record. Enemy forces, both German and Japanese, began altering tactics to avoid the night fighter threat. German bomber crews, previously confident under darkness, were forced to fly higher, change routes, or delay operations, while Japanese reconnaissance and strike missions became more cautious and less effective. The mere presence of the P-61 altered enemy calculations, creating a psychological advantage that complemented its physical firepower. Commanders reported that enemy pilots increasingly referred to ghost planes haunting the night skies, a direct acknowledgement of the aircraft's deterrent effect. The aircraft also transformed American thinking about technological integration in warfare. Radar, once experimental and peripheral, became central to air combat strategy. Crew coordination evolved into a standard requirement, emphasizing teamwork, communication, and trust in instruments over visual cues. The success of the P-61 influenced subsequent U.S. designs, including jet power night fighters and specialized interceptors, establishing a framework for integrating electronic detection systems into combat aviation. In many ways, the Black Widow laid the foundation for modern aerial warfare doctrines centered on intelligence, electronics, and tactical precision. Morale and national confidence were additional, less tangible effects. For American civilians and service members, the knowledge that U.S. forces could now counter night raids provided reassurance. Industrial workers saw their efforts translated into a tangible advantage in battle, while pilots and air crews took pride in operating an aircraft that combined cutting-edge technology with battlefield effectiveness. The Black Widow became a symbol of ingenuity meeting necessity, a machine born of vulnerability, yet capable of shaping the course of engagements far from home. By the end of World War II, the P-61 had proven its value, leaving a clear legacy. It was the first American aircraft designed and deployed specifically as a night fighter, successfully integrating radar, advanced armament, and crew specialization. Its impact was measured not only in confirmed kills, but also in the strategic and psychological disruption it imposed on enemy operations, the lessons it imparted to American aviation, and the foundation it created for post-war air defense innovations. The Black Widow had moved beyond its initial role as a solution to a vulnerability. It had become a transformative instrument of war, demonstrating that human ingenuity, technological innovation, and strategic vision could converge to dominate even the most challenging environments. Its story, however, is not merely about victory. It is about the broader significance of adaptation, courage, and foresight in the face of unprecedented challenges. The P-61 Black Widow was more than an aircraft. It was a testament to human ingenuity under pressure. Born from necessity, it addressed a vulnerability that could have left the United States exposed to night attacks. Its design, twin engines, 3 specialized crew members, integrated radar, and concentrated firepower, represented a leap in both technology and strategy. But beyond the specifications, the Black Widow embodied the courage, persistence, and vision of the men who created and flew it. Engineers worked tirelessly in frozen hangars. Pilots and radar operators trained under dangerous conditions, and military leaders pushed for innovation while balancing the weight of national security. The aircraft changed the nature of aerial warfare. Night, once a haven for bombers and reconnaissance planes, became contested space. Enemy pilots learned caution, altered tactics, and were forced to contend with a weapon that could see and strike where human eyes could not. The Black Widow demonstrated that innovation, coordination, and adaptation could overcome what once seemed insurmountable. Its legacy influenced post-war designs, the integration of electronics into combat aviation, and the development of specialized night fighters around the world. Yet perhaps the most enduring lesson is human. The Black Widow shows how necessity can catalyze invention, how danger can sharpen focus, and how courage extends beyond the battlefield to workshops, laboratories, and airfields. It reminds us that technology alone is never enough. It is the people behind it, the thinkers, builders, and operators, who transform ideas into power. As the war drew to a close, the Black Widow returned from the night skies to hangars and history books. Silent now, it stands as a symbol of what can be achieved when ingenuity meets urgency, when vision confronts limitation, and when a nation refuses to remain vulnerable in the darkness. In the story of the P-61, the night was conquered, not by luck, not by chance, but by determination, innovation, and the unwavering human will to meet a challenge no one had faced before.